Today we are going to be talking about functions and relations. So a relation is any, guys, a relation is any set of ordered pairs, which are just points. So some examples of relations. We use set notation, which are these fancy brackets. And then within these brackets, we have a list of points. Okay, so again, using these brackets here, this is called set notation. When we are talking about the domain and range of a relation, so when we have just a list of points, so we're going to learn two different ways to do domain and range. Today we're just doing one way when you're just looking at a set of listed points that's given to you. And so to find the domain deals with x values. So it's just a list of the x values in these, they're listed in those brackets, the fancy brackets. They have to look like that. You can't draw just like the square brackets because that means something different in math. So I know these can be difficult to draw sometimes, so do your best, squiggly brackets, to make them look different than the square brackets. So for example, if we were to do the domain of the example above, we would just list the x values. So that's -1, 3, and 6. And then the range is the same idea, but with the y values. So the range is the list of the y values in those brackets. So again, for the example, we'd have our range and then the fancy brackets. And our range is the numbers 2, 7, and 1. I like to put them in order, but you don't have to as long as you have all of the numbers within those brackets. Okay, so can you guys try example 1A and B? So you're just identifying the domain, so the x values, and the range, the y values for both of these sets here. Make sure you practice drawing your fancy brackets. We'll go over it in a second. All right, so for letter A, for the domain, make sure that when we're listing the domain and range here that you do label it somehow. You can just write D, you don't have to write domain, but make sure there's some way to identify which set is which. And we just list our x values, so 0, 3, and 90. And then the range is the list of our y values, 1, 22, 34. Questions on that one? Okay, then letter B, again, our domain is the x values, 2, 4, 11, -21. Again, I like to write them in order, but you don't have to as long as you have all the same numbers in there. And then the range is our y values, -5, 31, -11, 3. If a number occurs twice, so if you have like two of the same x values or two of the same y values, you don't have to write it multiple times. You just have to write it once. So you're just listing the different numbers that occur in the domain and the different numbers that occur in the range. So you don't have to list a number twice if it occurs twice. Okay, so now specifically a type of relation is a function. So this is a relation where each x value has only one y value. So that means we can't have an x value that takes us to two different y's. Every x value can only have one y value that it's matched with. So for example, right below it, if we had the points like 1, 2, and 3, 4, we have two different x values. The x values don't repeat, so we don't have to worry about it. This one would be a function because we don't have to worry about the same x value going to the same y value. But if we had an example where we had like 1, 2, and then 1, 7, here we have the same x value, 1 and 1, but it's taking us to different y values. And so since this x value is taking us to two different y values, that would make that one not a function. So you're just looking for if your x values repeat, you have the same x value, and then you need to just see if it's going to the same y or a different y. Okay, let's do an example. So this is just going to be example or practice identifying if a relation is a function or not. So again, to determine if it's a function, we're going to have a checklist. The first thing you're going to do is ask yourself, do the x values repeat? So is there any x value that occurs multiple times? If the answer is no, then it's a function. If the answer is yes, then you have to ask yourself, does it have the same y value? If it does have the same y value, then it's a function because that's just listing the same point again. If it doesn't have the same y value, like that example that we did on the front side, then that would not be a function. Okay, so let's take a look at our first example, 2a. So first thing we do is look at our x values. We have -1, -4, 1, and 8. Do any of our x values repeat? Do any of our x values repeat? No, so this is a function. Letter B, we have 13, 13, 6, and 18. Do any of our x values repeat? Yes, we have 13 and 13 here. So then we need to look at the y's. Are the y values the same for those 13s? No, these are different, which makes this not a function. Okay, can you guys do C and D, determine if it is a function or not? All right, letter C, is it a function or not? It is, yes. We have our 4 different x values. None of the x values repeat, which makes this a function. All right, what about letter D? This one is a function. So even though we have a repeating x value, we have a 1 and a 1 here, the y value that goes with it is the same. It's a 3 for both of them, which means it's just the same point. And so that is still a function. So just remember, x values can't repeat, y values can. So make sure when you're trying to determine if it is a function or not, you're always just looking at the x values first, not the y values. All right, so still in the same idea here, determining if a relation is a function or not. Example 3, for the following relations, in order to be a function, x cannot be what value? So we just want to see what value of x would cause this set of ordered pairs here to not be a function. So remember, to not be a function, that means our x values are repeating and it has a different y. So if our x values are 8 and 3, if this x equaled 8 and 3, that would cause us an issue. So if x equaled 8 or 3, say that again? What? Oh yeah, we're not solving it or anything. It would cause this to not be a function. Because if x equaled either of those, it would have a different y than the other point. Our second one. So what values of x here would cause this to not be a function? 5 and 8, why not 6? Yeah, because if x equaled 6, then it'd be the same point, 6, 7. So the only ones that would cause this to not be a function are 5 and 8 again. 5 and 8 would cause it to not be a function. Okay, so this is how you can identify a function if you are just looking at a list of points, if you just have your set of ordered pairs there. There is a way that we can determine if a function is or if a graph is a function just by looking at a graph. And we can use what's called the vertical line test. And so this test says if you draw a vertical line through all points of a graph, and each line hits the graph only once, then it's a function. So what that means is when you have a graph, you just take your pencil or your finger and you just go vertical line across your graph to see if this line will hit the graph at more than one point at any time, or you can just draw a bunch of vertical lines. So here it hits it only once, only once, only once. So this graph, every time you draw a vertical line, that line is only going to touch the graph at one point, which means this one is a function. Whereas if we look at letter B, if we draw vertical lines, like that vertical line is hitting our graph at 2 spots. This graph is hitting our line at 2 spots. We could, if we draw right on the edge here, we could get it so it only hits once, but that doesn't matter. If at any point a vertical line would hit the graph at more than one point, that would make it not a function. Because that means that this x value here is taking you to 2 y values. And the definition of a function is that each x value only takes you to 1 y value. So letter C, if we start drawing vertical lines, it looks good right off the bat. We're only hitting it once, but then once we get here, oh no, we're hitting the graph 1, 2, 3, 4, 5 times. So this one would not be a function. Okay, so again, there's two ways to determine if it's a function, looking at the ordered pairs and looking at if the x values repeat, and then looking at a graph and doing the vertical line test. All right, one last thing we need to go over today is function notation. So this is basically just a different way to write the equation y equals by using letters. So we can use f of x. Or we can use any lowercase letter instead of f. Any lowercase letter. So you could have g of x or h of x, etc. So this notation just gives us a way to know what the y value is and the x value at the same time. If we were just to use the y equals notation and I just said like y equals 7, I only know the y value. I don't know the x value that gave me that. If we use function notation and we write f of 3 equals 7, then that means this 3 is the x value and the 7 is the y value. So it gives us the opportunity to see both the entire point, x and y, together in one notation. Okay, so the number in the parentheses is the x value. The number that it equals, f of x or g of x equals, is the y value. Okay, so to evaluate a function, and we've done this before, we're simply going to replace the x with whatever number we're being told it equals and solve. So example 5, if we have f of x equals 5x plus 2, we want to find f of 3. So again, this is telling us, this is telling us if x equals 3, what does y, or f of 3, equal? So we just take our 3 and we plug it in for x. So we'd have f of 3 equals 5 times 3 plus 2. So this f of 3 here in the parentheses, this is not f times 3. This is not an operation that's happening. This is notation. This is just telling you y equals. This is what you're solving for. So we don't need to do anything to this. This just stays f of 3. But then we can do our order of operations here. We do this multiplication. 5 times 3 is 15, plus 2 gives us 17. So f of 3 equals 17 would be our answer. This means we have the point. Again, our x value is 3, y value is 17. Okay, letter B, f of negative 5. So again, this is telling us that x equals negative 5. We want to find what the y value is, or what f of negative 5 is. So we take this negative 5, plug it in for x, with parentheses. Whenever you plug something in, you always need parentheses. So we'll have f of negative 5 equals 5, and then in parentheses, negative 5 plus 2. It's important that you use parentheses, because if you just write 5 and then negative 5, that will look like 5 minus 5. But that's not what's happening. The equation is 5 times x, so we have to make sure we're multiplying there. So again, this f of negative 5 here, that's just what we're trying to solve for. You're not doing any operations there. So f of negative 5 equals, we'll have negative 25 plus 2, which will give us f of negative 5 equals negative 23. And again, once you get down to one number, that is your solution. And again, negative 5 is our x value, negative 23 is our y value. Okay. And can you guys try letter C real quick? So f of 0. And what does f of 0 equal? 2. Yeah, if you plug it in, you'll have equals 5 times 0 plus 2, and 5 times 0 is 0. So it's with f of 0 equals 2. Okay, so again, x value, y value is the point 0, 2. So since x equals 0, this is also the y-intercept, fun fact. All right. So just plugging it in, the notation just looks a little bit different than when we just had plain old y equals. Now we're just using function notation instead of y. So example 6, this is it's the same idea, function notation. So f of x equals 2x squared minus 2x. We want to find what f of 3 is. So this is telling us x equals 3. And so you plug this 3 into your equation wherever you see an x. So it'll be plugged in to the x squared and to the x at the end. It plugs in everywhere with parentheses. So we'll have f of 3 equals 2, then parentheses 3, then you close the parentheses. The parentheses go just right where the x is. Then the squared is happening on the outside. Minus 2, and then parentheses 3. So order of operations, we do our exponent first. So 3 squared gives us 9. Then we do our multiplication. Which will leave us with f of 3 equals 12. Again, 3 is our x, 12 is our y. Okay, so it's the same idea, you're just plugging in the x in 2 different places. Okay, can you guys try B and C? Again, be very, very careful with parentheses, especially with letter C. So go ahead and try those. Plugging it in. All right, f of 2. What does f of 2 equal? Hello? First hour? 4, thank you. Yes, f of 2 equals 4. So again, 2 is our x, 4 is our y. I'm going to keep saying it just to make sure you remember. F of negative 4, what does that equal? 40? Do we agree? That one wasn't as loud and convincing as letter B. Would you like me to go over it? I'll just do it because I like math. Okay. So 2, and then in parentheses, negative 4, close the parentheses squared, minus 2, then negative 4 in parentheses. We do our exponent first. This is negative 4 in parentheses squared, which is a positive 16. Then we do our multiplication. And a negative 2 times a negative 4 would be a plus 8, which is what gives us 40. So again, f of negative 4 is our x, 40 is our y. All right, do you guys have any questions?